Way out at the edge of our solar system, there's this really cool cosmic mystery playing out. It's all about the strange and, frankly, disappearing atmosphere of the dwarf planet Pluto.
So you gotta ask, right? How can a world that's smaller than our own moon, just hanging out in this deep freeze, it's nearly 40 times farther from the sun than we are, how can it even have an atmosphere? How can this little ball of ice and rock breathe?
Well, that's the whole mystery, isn't it? This is where our cosmic detective story really kicks off. Because, believe it or not, Pluto does have an atmosphere. A real one we can measure. But here's the catch. It's only there sometimes. It's like a ghost that shows up and then vanishes over hundreds of years. All right, first up, let's dive into this ghost atmosphere and really unpack the puzzle of this frozen little world. Okay, to get a handle on just how weird this is, you have to think about what Pluto is up against. It's tiny for one, and it's so far from the sun that the sunlight it gets is just incredibly faint. I mean, by all rights, it should just be a completely frozen, totally static world.
And even when this atmosphere is around, it is unbelievably thin. We're talking about a surface pressure that's just 1/100,000th of what you and I are feeling right now here on Earth. It's not an ocean of air like ours, it's more like a whisper.
So what's in that whisper, you ask? Well, it's mostly nitrogen, actually. A lot like our own atmosphere. But it's also got little traces of methane and carbon monoxide. And here's the really crucial part. These gases aren't bubbling up from volcanoes or anything like that. Nope, they're coming right off the frozen surface. And that little fact leads us straight to the science that powers this whole thing. Let's talk about how you get ice into gas, the real engine behind this atmosphere. Okay, the magic word here is sublimation. You've probably seen this if you've ever played with dry ice. It's that cool process where a solid turns straight into a gas. It just skips being a liquid entirely. On Pluto, it's the frozen nitrogen on the surface that does this, turning into a gas with just a tiny little nudge of energy. So you see, this is totally different from Earth. Our atmosphere is kept going by heat and geology from inside the planet. Pluto's? It's all powered from the outside. It literally only exists because that super faint distant sunlight gives it just enough of a kick to lift those gases right off the ice.
Okay, so what pulls the trigger? What starts this whole sublimation engine? The answer is out there in space, in the celestial triggers of Pluto's amazing orbital dance. Trigger number 1 is Pluto's absolutely wild orbit. Look, Earth's path around the sun is pretty much a nice, predictable circle. Pluto's, on the other hand, is this long, stretched-out oval, and what that means is that its distance from the sun and the amount of heat it gets changes a lot. And get this, one trip around the sun for Pluto takes 248 of our years. It hit its closest, warmest point back in 1989. That's when its atmosphere was at its peak. But now it's on the long journey back out into the cold. By around the year 2113, it'll be at its farthest point, and that's when the deep freeze really sets in. Most of that atmosphere is just going to collapse and freeze right back onto the surface. All right, the second trigger is just as bizarre. It's tilt. Pluto is tilted over by a whopping 120 degrees. It's basically spinning on its side as it goes around the sun, and that causes the most extreme seasons you can imagine. We're talking decades-long seasons, where one pole gets blasted by sunlight for over 60 years straight, while the other side is stuck in a long, dark, frozen winter. So we had all these theories, right? But they were just that, theories. We needed to get up close. And that brings us to the climax of our little detective story, the absolutely game-changing flyby of the New Horizons mission. So back in 2015, NASA's New Horizons spacecraft zipped past Pluto and just wow, it completely rewrote the book on this place. Suddenly, we had this incredible new picture. We saw a complex, multi-layered haze reaching way out into space. We found evidence of winds, and the big one, we found this massive reservoir of nitrogen ice. You know, you can really boil down everything the mission found into one powerful quote from the science team. They said Pluto was, simply, a world far more active than we imagined. I mean, nobody saw this coming. And the key to all that activity? It's a place called Sputnik Planitia. You know that famous heart shape on Pluto? Well, this is the giant basin of nitrogen ice that makes up the left side of it. This is the engine room. It's the main fuel tank, constantly feeding the atmosphere as that ice sublimates, slowly releasing the faint heat it's stored up from the sun. So what happens now? What does the future hold as Pluto keeps moving farther and farther away from the sun? Well, this is the story of its fading breath. We've actually been watching this whole cycle from Earth. After we first detected the atmosphere in 1988, the pressure actually doubled by 2006. It was kind of coasting on leftover heat. But by 2018, the tables had turned. The trend reversed. The Great Collapse has officially begun.
But here's a final, really fascinating twist. The atmosphere is definitely thinning out, but it's not happening as fast as we thought it would. And the reason is something called thermal inertia. Just think about pavement on a hot summer day. It stays warm for hours after the sun goes down, right? It's the same idea. That huge sheet of nitrogen ice is holding onto its heat, kind of putting the brakes on the deep freeze. This whole epic cycle, growing an atmosphere when it gets close to the sun and then losing it again out in the cold, it's earned Pluto a pretty cool nickname, the King of the Comets. Because when you think about it, it acts just like a giant, majestic comet, breathing out this temporary atmosphere only when it gets close to the fire.
So as we watch Pluto's ghostly breath fade back into ice over the next 100 years or so, it leaves us with this really profound question. We all thought it was just a dead, frozen rock, but it's not. It's alive with these incredible, majestic, slow-motion cycles. It really makes you wonder, doesn't it? What other amazing secrets are these frozen worlds hiding from us?